There we are. Thank you. So now at this time, we ask that you please mute your mics for the best sound experience. Otherwise, feedback could interfere with the information we will be sharing with you today. Without further ado, here is Mr. Azasi.
Hello, everyone. My name is Alberto Isasi, and I'm an instructor at the Trans Mountain campus. Today's workshop is going to be about factoring. I truly believe that factoring is very crucial for for other courses in math. Especially for the remedials and also for the upper level classes. Okay, now how I present my factoring classes. When I teach, I give the students a handout. I'm going to share the handout with you. Okay, I'm going to share my screen and I'm going to tell you about the handout and how that's connected to the PowerPoint that I'm going to present. Okay, I'm going to share my screen, and this way I'm going to go get the. You know what? Let me go get the file. I'm going to share the file and then I'm going to share my screen to get the PowerPoint. Okay, so let me go get the file that I want to share with you guys. And these steps to factor are from the book, but I just kind of modify it. It's like a little map for the students so they can know exactly what to do. Okay, let me see here. Can you guys see my screen there where it says factoring steps? Okay, now guys, thank you. Well, let me continue. If you guys want to make it bigger, there's like a little box on the left corner with a little circle like a magnifying glass. Just click it there, and then you can zoom in and zoom out. Okay, so these are the factoring steps that I give to my students when I teach we either Math 305 or even 1314, 1324, because I'm surprised at times when students come back to school at a later age, they forgot how to factor. So then, in a way, it's kind of hard for them because if they don't know how to factor, especially in pre-cal, they're going to lose out. So what I do every first Sunday of the semester, I do something numbers, and I go over factoring. I invite other students that are taking math, for example, 0305, the NCBNs, pre-cal 1, pre-cal 2, 1324, cal 1, and they're invited, and I show them how to factor. So this way nobody gets left out if they follow this method here, because if you remember how to factor, or you're like a little rusty, you'll be able to catch up quick. My way of teaching is that I don't want nobody to be left out, because at times when a student is left out, for example, if he or she is behind in factoring, they don't know what to do. So the more or less they're gonna quit the class. Okay. So anyway, my first step to factor is find the GCF, and my second step is determine the number of terms. All these steps I'm going to go over the PowerPoint except for this one here for perfect cubes. Okay, because the PowerPoint is only like an hour, and it would take me like close to 2 hours to present it every Sunday when I do Sunday numbers. Okay, I'm sorry. Let me go back. So then, first of all, it's a GCF. Then the second step is determine the number of terms, and you have to make sure that the terms are in order. If not, you have to rewrite them from highest degree to the smallest degree, up to the constant. So if it's two terms, then this is what you do: is perfect squares or perfect cubes, right? So these are the formulas or the way to factor with two terms. If it's three terms, then it's either going to be the easy factoring, which I call it x squared plus bx plus c, or by this. I like to do the grouping part because at times when you do a trial and error, some of the students can get a little bit confused because they have to know how to multiply and to add real good. Okay, and then it comes with four terms. So these are the steps that I'm gonna go over in the PowerPoint. Okay, except for step here for 2A. For two perfect cubes. Okay, now I also give the students this handout because at times students that are out of school for a while, they might forget what are the factors. So this handout gives you all the way factors from 1 to 100, okay? And this is very easy to use, and this is just like a calculator. It depends on your instructor. For example, when you take remedial courses, if you're permitted to use this. In my class, I didn't use it, but not for the exams, okay? Only like for the homework and stuff, but not for the exams. Like for example, if if we get the factors, say we're trying to find something in common, right? Like the GCF, say between 12 and 14. So I'm going to show you in the PowerPoint how to list all the factors. But here with this handout, it's very simple. For example, if you have 12 and 14, you look at the factors, and if you notice, 2 is the highest or the greatest common factor. Say between 20 and 30, right? So we have 1, 2, 4, 5, 10, 20, and 1, 2, 3, 5, 6, 10, 15, 30. So my GCF will be 10. And again, on the PowerPoint, I'm going to show you step by step without using this handout. But this handout, I tell my students to relate to it, and it's just like a calculator. Okay? So now, with that said and done, now I'm going to share my screen and go to the PowerPoint. Okay. Okay, let me share my screen. Okay, let me go here. Oh, here we go. Can you guys see the PowerPoint?
Yes, sir.
Okay, okay, thank you, because I won't be able to hear you guys, okay? So I'm going to start. Yes, I have another computer here, and I logged in as a participant. This way I can see what I'm doing here, okay? Okay, now, so let me start the PowerPoint. Okay, now, this is a factoring workshop, and these are the courses that require factoring. For example, these are the NCBNs, which is 0114, which goes with 1314. You take these two at the same time. Or this one here, the 0114, is a 1 credit course. Okay, so this goes, for these two, you go once a week when it's lecture. And if it's online, it's only 1 hour. And these here, the 0314 and 1314, they also go together, and they're 3-hour courses. Same thing with NCBN for 0124. This one goes with 1324, or this can go with 1324, or the 1324 by itself. And also there's 0305. Chapter 6 shows the foundation of factoring on the book 0305. Okay, why is factoring important? If you notice, for the majors, like for business and accounting, you must take 1324 and 1325, which is a business math, or the analysis business, or the calculus business. This is a 1325. And also for the majors going like for math, computer science, engineering, and I believe also biology, you have to take to a certain, you have to take all the way to maybe 13, 14, all the way to differential equations, or maybe all the way to Cal 1. But all these courses require factoring. And as an instructor, when I first started teaching at the college, I was real surprised that at times students are in pre-Cal 1 or calculus 1, and they don't know how to factor. And most of the times, it's those students that took a break from college. So I figured, how can I reach those students? So I began trying to find ways how to find, for my teaching style to reach every student, for none of the students to feel like they're left behind. Because when I teach, I don't like to leave nobody behind. And if they're struggling, I try to come to my class or to my office hours so I can more or less help them catch up. But like I said earlier, this workshop that I'm presenting right now, this is what I do every first Sunday of every semester. But since the classes are going online, I don't do it because this is really like, it has to be like live. And with this PowerPoint, Mitsuka mentioned that I could do the animations if I share my screen. And golly, that never occurred to me until Mitsuka told me to do it this way. So I'm real proud, and I'm real happy that Mitsuka told me to share my screen with you guys. Okay. So anyway, so what's the purpose of factoring? The purpose of factoring, quadratic expressions is to eventually to lead to a method of solving quadratic equations. A quadratic equation is something that has to the degree of 2. And the purpose is to find these intercepts here. These can be called the intercepts, the solutions, zeros, or roots. They all mean the same thing. Okay, for example, when you're graphing, these are called the intercepts. You see, and this one over here too. So that's you must factor and then use the zero property theorem to find the intercepts or the solutions, zeros, or roots. That's what's crucial when you take the upper level math courses, because everything is about solving or finding the x-intercepts or the solutions to certain quadratic equations, even polynomials. Okay, now I like to always share a lot of examples, because at times students might say, hey, Mr. Isasi, well, I'm never going to use this. So why should I learn it? And then I begin to make connections with the importance of the topic at hand, so they can relate to a real life problem. For example, how does this bridge over here on top relate to factoring? Well, to find the x-intercept or to find this point here and here, you have to know how to factor. Okay, and for example, this is like a bridge. This one doesn't have no solutions, but that's another story. That's when you take these are called imaginary solutions, but that's, for example, when you take I believe 13, 14, or you'll be able to learn what that means. And here, this picture here at the right, there's a whole bunch of quadratics, but this is like a polynomial because it has a whole bunch of different quadratics. Anyway, these are examples of quadratics or polynomials. Okay, but for example, a quadratic is something like with an arc, like the Lagrange's arc. Okay, so how do you use it? Like, for example, the one on the bottom, which says profit and cost. This can be an example of the course 1325. How do you deal with money? For example, here it's saying that the x-axis is my cost and my y-axis is my profit. So these right here are your intercepts, and you get them by factoring. Okay, and then when you do go for 1325 as a major, like for business or for accounting, it's all about making money, either for yourself as a business or as an accountant to make money for other people. But it's all about making money and profit. Okay, now this one here in the middle, it's how it relates like to sports. I like to play sports. That's why I came up with this. I got this little image. Because at times, students might say, well, I don't know how it would fit me. And then I think everybody plays some kind of sports, whether it's football, basketball, or soccer. So in soccer, it's at times, this is real like, what's it called? The word that I'm trying to say. This is current right now. A lot of people play soccer, especially here in the United States, because in the past, hardly nobody played soccer in the US, but now that's something that a lot of people are playing soccer. That's why you use this image here. So again, these are the intercepts here, okay? And how to find the highest point, and which is called a vertex. That's, like I said, that's not the topic for today. And here's another picture, like an image, where also you must factor to find where this person here hits the ground here. Okay, that's also the x-intercepts or the solutions. Okay. Let's see how. So this slide here is a slide that I showed you at the beginning, what I shared with you. Remember the steps to factor? They're all right here. So I'm going to do 1, 2, 2a, and 2a, but only the perfect squares, and 2b, and 2c. I'm going to show you examples of each one. Then at the end of the presentation, we're going to give you some problems for the students to work out, or for the others to work out, and then the Shuka or I or Ruben will work them out. I'm going to use an eraser board if they want me to do them in an eraser board, or else I think Ms. Chuka and Mr. Carizales, they're going to use the blackboard, whiteboard. Okay, but we'll decide what happens when we get there. Okay, now, so for example, during Sunday numbers, everybody has this handout. I tell students to present this handout, or I give this handout and the factors from 1 to 100. So I tell them, you know what? So the first thing you got to do, guys, is see what the GCF is. What's the highest factor to factor out? And then step number 2, after you do step 1, you go to step 2. Determine the number of factors. No, make sure terms are in order. Because at times, I mean, the author of certain textbooks, they try to make sure that you know what you're doing by rearranging the order of the polynomial or the quadratic, which at times, but you have to put them from highest degree to smallest degree. For the students that don't know what the highest degree is, for example, when you have I mean, a variable, right, or the letter, which are called variables in math, the highest exponent. You put it from the highest exponent, and then you keep going all the way until you have no exponent. Okay? That's what it means by rewriting in order. And then if it's two terms, it's either going to be perfect squares and perfect cubes. And if it's three terms, I call this the easy factoring, guys, because you're going to notice that it is very, very easy. Because if I tell the students, you know what, yeah, it's a little bit hard or stuff like that, right away, the word hard, right away, the students begin to freak out. I mean, especially if it's been a while since they've been in school. So that's why I call it the easy factoring. And if you can give me your honest opinion at the end of this presentation, you tell me if it's easy or not. Because everybody tells me, hey, Mr. Isasi, the way you factor is very, very easy. I mean, I didn't know how to factor, and then when I came to the Sunday number the first Sunday, everything came back to me. So I mean, I get real happy when people tell me that, because it means that my work that I'm doing is not in vain. Because our goal as instructors is to reach every student. We don't care how, but we got to reach them. Okay, now, and then I'm going to do this here, the two here, I mean, the three terms, it's either by grouping or by trial and error. Trial and error is a little bit more challenging, because trial and error, you have to be real good with multiplication and adding or subtracting. And grouping, they're just like steps, which I'm going to show you. I was surprised, guys, when I actually did my internship at a high school here in El Paso. I never knew how to do it by grouping. I always learned how to do it by trial and error. So I was doing, I mean, the instructor told me to take over the lesson, and it was factoring in this form, ax squared plus bx plus c. So then I began doing the tedious work of, I mean, factoring in that manner by trial and error. And the students, I mean, I would look back, and the students were looking at me kind of crazy, like saying, what in the world is this guy doing up there? So then after I was done, I felt so happy, because I thought that I did a good job. But then the instructor told me, hey, Mr. Isasi, we don't do it like that here. I said, what? And he mentioned we do it by grouping. And I said, I had never heard about grouping. So I asked him, well, show me. And after that, it made more sense, because I believe in some of the high schools, they don't do it by trial and error. Because, I mean, I'm not sure. But that's what the instructor told me, that they did it by grouping in that school. Okay, but I don't want to say which one. And then 2C, guys, is by grouping. Okay, so as I said and done, I'm gonna follow the PowerPoint, and remember, guys, this right here, guys, that 3, 4, 2 factor means you're gonna start with 3 terms, 4 terms, and 2 terms, and then factor. So when I say, remember, guys, about factoring in this form, remember about the 3, 4, 2 terms. This is what I'm talking about here. Okay, so let me continue then. Okay, the vocabulary that we're gonna be using here is just quadratic expression. I'm showing examples. Quadratic expressions have the highest power of 2, or the degree 2. These are examples. Okay. And the other key word that we're going to be using are factors. What are factors? Factors are numbers multiplied together to get another number. For example, what are the factors of 12? We can multiply 1 times 12, 2 times 6, 3 times 4, right? So these are all the factors of 12. So, hey guys, remember the handout that I showed you at the beginning, the factors from 1 to 100? If you look at the number 12 there, it's going to show you all those factors, so you can get them from there too. Okay, but it's always good to know exactly how to get them, without no handout and without a calculator. Okay? So then, what are the factors, example 2, what are the factors of 20? 1 times 20, 2 times 10, 4 times 5, right, and so forth. So these are the factors of 20. 1, 2, 4, 5, 10, and 20. So all these are called factors of 12. And these are all factors of 20. Okay, now the other keyword that we're going to know is called the greatest common factor, keywords, which is called the GCF. The GCF of a set of numbers is the largest factor that all numbers share. Okay, what does that mean? Well, let's see an example. Let's get the example that we're here, right, that we just used. What is the GCF of 12 and 20? Again, here's the definition. The GCF of a set of numbers, you'll see these are my numbers, is the largest factor that all numbers share. Or, in other words, what's the highest number they have in common? That's another word. If you notice, these are the factors of 12, which we had right here, and these are the factors of 20. So from here, these are the numbers that they have in common, right? 1, 2, and 4. So from the numbers that they have in common, what's the highest number? Which is the greatest, numbers of the GCF of 12 and 20 is 4. Hey guys, and this is crucial when you begin to factor, because that's going to be your first step. And at times, students forget to do this step. That's why the answer doesn't come out, because they didn't factor out the GCF. That's why when I teach my classes, guys, I always tell my students, hey guys, what's the first step? Okay, GCF. What's my second step? I always keep, it's like I'm like a machine being recorded over and over again, so the students can have it in their heads. You know what I'm saying? That way they don't have to use a handout. They can do it in their heads. Okay? Okay, now, so let's do examples of GCF, greatest common factors. What's the GCF of 20 and 30? Find the factors of 20 and 30 like we did earlier, right? So 20, how can we get 20? 1 times 20, 2 times 10, 4 times 5. So those are the factors of 20. Okay, at times, guys, I like to get the audience to participate, but in this case, right, it's kind of obvious, right, the factors of 20. But you guys are going to get to participate later on with this PowerPoint. That's why this PowerPoint is amazing. Why? Because I can get the audience attention, right? I can ask questions, and then for them to give me their feedback or their answers, and then we'll see if it's right or wrong. Okay, so now, how can we get 30? 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So these are the factors of 30. Okay, now, when I tell my students, do not always try to go in order, because at times the number that we're trying to look for, say it's 60 or maybe 84, and there's too many factors. So if you try to, think about them in your head, it's going to be a little bit difficult because you don't know if you already have all the factors. So it's always wise to put them in order, like the way I have it here. Okay, but you guys can do whatever, right? But this way nobody gets left behind. If you know what the factors are, the GCF is more power to you. But if you don't, here nobody gets left behind. They can follow these steps and they know exactly what to do. So these are the factors, right, that they have in common: the 1, the 2s, and the 10. So what's the biggest number that they have in common? It's 10. Okay, now, so what's the GCF of x and x cubed? Here's where a lot of students begin to make mistakes. Okay, but before they know about GCF, they will have to know the power of exponential powers. For example, if you have x to the m times x to the n, right? You add the exponents. That's crucial before they take this course, because if not, they're gonna have a hard time trying to understand this. But the way I break it down, guys, is very, very simple. Okay, check this out. So x squared is x times x, and x cubed is x times x times x. So what's the GCF? So how many do they have in common? They have 1, right? 1. They have another 1, but it's not 2x. They have x, right? So it's going to be x times x. So that's why it's going to be x squared. Okay, you multiply them. You don't add them. Because, for example, here, right, they have 2 x's in common. It's not 2x. You multiply the x's. Okay, now, observation. Okay, here's what I tell my students. Observation. If both terms have the same variable, which is the same letters, the variable with the smallest degree is a GCF. Okay, for example, between x squared and x cubed, right? They both have an x, both terms. So which one's is the smallest one? 2 or 3? So 2. So that's my GCF. I should have given guys more examples, but this PowerPoint I presented it during developmental week. I think in the fall. It was the last time that we did workshops that were face to face, and I use this PowerPoint for my students, and they tell me that they can actually know how to factor just by following the PowerPoint. They give whatever numbers, which I'm going to show you right now how that works. Okay. So now let's factor out the GCF. Here's what it's all about. Okay, we're going to factor out the GCF. So the GCF, right, what's the common factor between these two terms? If we notice the 30, right, we did it here, between 30 and 20, it was up here, right? The number. And the letters, right, or the variables, Hey, students, it's real good to know the vocabulary. These are called variables, but at times students, they don't know what they mean. So I mean, that's why I always say both words, variables and letters. They mean the same thing. But in math, they're called variables. So for the variables, right, it's going to be x squared. So for the numbers, it's 10. And for the variables, it's x squared. So now, right, so that's my GCF. So I'm going to factor it out. So if I factor it out, right, if 10 squared is factored out, what's left? And here's what I tell my students, okay? Because it would take too long to put them in primes. And I believe that's the way they show them, to put them all in primes, and then you take it from there. But like I said, when somebody comes in, like from, like say for pre-cal 2 or calculus 1, I don't have time to teach them in prime. So this is the way I tell them. Okay, now, you can do it two ways. You can ask yourself, 10 times what will give me 30? Or 30 divided by 10 is what? Which is 3. And then I tell them, we have x squared, right? We need x squared. So how many x's do we need? We don't need none, right? And then the plus or the sign here comes down. Now here, the same thing. I like to use multiplication. So I like to tell my students, what number, 10 times what number will give me 20, which is 2. We have x squared, we have x cubed. So how many more x's do we need? We got 2, we got 3, right? So we need 1. And here's where we use the rule for exponents, when you multiply exponents. So it's going to be x. Because the rule is, right, there's supposed to be like a 1 there. So 2 plus 1 will give me 3. That's a rule when you multiply exponents with the same base. So then, that was my GCF. Okay, now, let me factor out the GCF. I'll continue. Okay, this is something from 6.1 in 0305. Example. Here's where those students begin to get a little bit confused. And I tell them, there's no confusion here. These are two terms. These are all together. And these are called binomials because they're in parentheses. But not to confuse my students, I tell my students, these is like a family because the family is together. You cannot break up a family. And at times, students ask me, Mr. Isasi, well, where does it say family in the book? No, it doesn't say family in the book. I just made it up. Because at times, some of the students, if I say binomials, some of the students, they don't even know what that is. But if I say family, right? Family cannot be broken out, then they know exactly what I'm talking about. But then I go back and mention, remember guys, the family is a binomial. Okay? Okay, now. So they have in common, right? They have in common the 2x minus 5 because remember, this is a binomial. So these two terms have in common the binomial of 2x minus 5, or for the people that don't know what binomials are, or it's a family of 2x minus 5. Okay, so, right, so this is what they have in common, right, in red. That's why I put it here in red, so you guys can see exactly what they have in common, or the GCF. So if 2x minus 5 is factored out, right, if I factor it out, what's left? Right, so if I take this out from this term and this side from this term, what's left? Anybody? Somebody, what do you guys think? What's left? Very good. X plus 2, my friend. Very good. So x plus 2. Okay? And at times, guys, I mean, here's where I get sarcastic. For example, people at times, they don't see this. So I get sarcastic by saying something like this. Okay, guys, I'm going to put a dog there. Say you have x dog plus 2 dog. What do they have in common? Well, the dog. So take out the dog then. And then, because like I said, I try to use some weird stuff for the student to understand. It might be kind of stupid to some student, but maybe for another student, the little light turns on. And that's what it's all about in math. But then I tell them that, okay, it's not a dog. I just use the word dog in there just to prove the point. But the real, I mean, what you hear in math, this is called binomial. They have the binomial in common of 2x minus 5. So what's left is x plus 2. Then I go back and reassure them that about the math language that you got to understand. So this is my answer, guys, right? So if you have x, 2x minus 5 plus 2 parentheses 2x minus 5. So this is my answer. Okay. Okay. Now this example is crucial for factoring polynomials with 4 terms. Remember the 4 terms, guys, in the handout, it was 2c. In 4 terms, you do it by grouping. Okay, now, You see, four terms is 2C factored by grouping, and this is all in that handout that I created for the steps for students to follow. Okay, now, this is the way the book explains it, okay? And like I said, every time that I do when I teach a course, I always tell my students, and especially with the 305, hey guys, if you guys can come up with an easier way to explain to other students, let me know. And then whatever idea you have, we'll show it to the class, and then we'll vote on it. If the students agree that your method, is better than what I'm doing, then after this point, I use your method, because it's always wise to get the input from the students. Once the input has come from the students, it means that all students, more or less, most of the students will understand it that way. Because at times as instructors, we throw it down the throat of the student, right? The way we know it, but at times students don't get it, so we have to use a different technique. And I'm going to show you, this is from the book, and I'm going to show you the way it was modified, okay? Okay, anyway, this is by grouping, right? So this is like group 1, right? Because it's going to be 2 groups. We group them in pairs. And this is group 2, okay? Okay, so group 1, again, we go back to what I did at the beginning, the factors of 2. How can we get 2? It's 1 times 2, right? It's these two here. Factors of 8, 1 times 1 times 8, and 2 times 4. So the factors are 1, 2, 4, 8. So the GCF between 2 and 8, the answer is 2. And you can actually put it in the calculator, and it can give you the greatest common factor, which is 2. Okay? Now, do they both have variables? Sure they do. So we have to do that one too. So group 1, again, factors of x squared and factors of x. So how do we get x squared? X times x. And for x, it would just be x. So the GCF of x and x squared is, right, it was x, right? So then the GCF of 2x squared plus 8x, we combine these. So it's going to be 2x. So I'm going to factor out the 2x then. So if I factor it out, what's left? X plus 4. And you can always check your work, because 2x times x is 2x squared, and 2x times 4 gives me 8x. Okay, now then the book does it this way. Okay, then the book does it this way. But here's where I did a little bit of modification, and I'm going to show you on the next slide. Then this one comes down, right? And then you do the same thing for group 2. And here I put some color coded so you guys can see, so students can be obvious that this is group 1 and green, this is group 2 and like hot pink. So group 2, right? The factors are 3 and 12. So how can we get 3? 1 times 3. How can we get 12? Those are the factors of 12. So what's the biggest number they have in common? Is 3. And now for the variables, does this have an x? Yes. Does this have an x? No. So they don't have no variables in common. So the GCF of 3x plus 12 is 3. Right? So now the 3 goes in there. So if I take out the 3, anybody, what's left from here? If I factor out the 3. Anybody, what's left right here? You're close, my friend, not quite. And there you go, x plus 4. Mr. Wolfgang, you almost got it. It's going to be x plus 4. And again, if you put 12 here, it won't work, because 3 times x is 3x, but 3 times 12 is 36. You see, this has to give me 12. So that's why you can do it this way. Right here, right? We need a 3. So it's going to be, here on this term here, 3 times 4 will give me 3x. It's x. And here, 3 times 4 will give me 12. It's 4. Okay? So anyway, but thank you for participating, students. So here, again, what do they have in common? Is what I did over here on the previous example, x plus 4. So what's left? 2x plus 3. So then what's my solution? X plus 4, 2x plus 3. Okay, now this is a modified way that I came up with, okay? Again, it's 4 terms. So check this one out. We have 2x squared minus 5x plus 4x minus 10. Factor by grouping, right, because it's 4 terms. So find the GCF of the first 2 terms, which are these 2 here. What's the GCF between 2x squared and 5x? Won't it be x? So we factor it out, right? So we factor it out. So then what's left? X times what? Right? Won't it be x times 2x will give me 2x squared, and x times negative 5 will give me negative 5x. Now, here's where I modified this, okay? Check this out. If this term can be factored by grouping, don't do it again. Don't do it twice. What was left after you factor it out, just put it over here on this side. And then bring the sign down. And then here you ask yourself, what number times 2x will give me 4x? So it's going to be 2. And then we check it by saying 2 times 12 will give me -10, so it's -5. So I know it works. Again, students, if this can be factored by grouping, whatever you have to factor out here, just put it over here automatically. And this way you eliminate a step. Because there can be some confusion when students try to factor when there's like a negative sign, and they get a little bit more challenging, and more likely you're going to get the wrong answer. So that's why I tell my students, once you get the first two terms, whatever that was left after you factor it out, that's what goes on the right hand side. And then you bring on the sign, and you ask yourself, what number times 2x will give me 4x? So it's going to be 2, and you can always check your work. So the GCF from here, guys, is 2x minus 5, right? And this is what I did earlier. So you factor it out. So what's left? If 2x minus 5 is factored out, what's left? X plus 2. Okay, now, this is a modified, I modified a little from the textbook. The binomial that's left, right, which is this one here, the binomial that's left, after factoring the GCF on the first two terms, will always be the same binomial left on the right side if it can be factored by grouping. If it won't fit, it means this cannot be factored by grouping. Okay, so that's like a heads up that I tell my students. Okay, now this is step number 2. Now remember, step 1, determine the GCF. Step 2, determine the number of terms. So again, make sure the terms are in order, and if not, write them from highest degree to smallest degree. So if it's 2 terms, is it going to be perfect squares or perfect cubes, right? Remember that I said that the perfect cubes, I wasn't going to do them till, I'm going to skip those because if not, this will take more than an hour. So anyway, let's do perfect squares. If you have x squared minus y squared, this will be x minus y and x plus y. Because if you happen to do the FOIL, like x times x will give you x squared, x times positive y will give you positive xy, negative y times x will give you negative xy, and negative y times positive y will give you negative y squared. So every time the middle term will cancel. So anyway, guys, these are also called conjugates of each other, right? Conjugates mean you have the same letters here or variables, and over here too, but different signs. And that's crucial when you take, say for example, that you want to rationalize the denominator or the numerator, okay, like for upper level classes. So it's good to know these right here, okay? Now, why can't x squared plus y squared be factored? Again, this is like another story. This is where the imaginary numbers come in, but this cannot be factored. They can be imaginary numbers, or the graph doesn't cross the intercepts. Okay, for this one, it doesn't cross the intercepts. Okay, but when it cannot be factored, when it's prime, it's either one of those two cases, which that's you're gonna learn on your course. Okay, now these are perfect squares. Perfect squares are what two numbers or what two variables multiplied by themselves will give you x to the fourth. Okay, right? So it's x squared times x squared. That's why this is a perfect square. X squared is a perfect square because x times x will give me x squared. So all these are perfect squares. Okay, all the way to 100, and they keep going forever and ever. Okay, now, so we have x squared minus 1 is equal to x minus 1, x plus 1, right? Because they're both perfect squares. X squared minus 4 is equal to x minus 2, x plus 2. X squared minus 9 is equal to x minus 3, x plus 3. What would that one be? Somebody. Can somebody tell me what that would be? You're partially right, because yes, x minus 7 and x plus 7. Very good. How about this one now? Hey guys, on this one, does it matter if the positive goes first or the negative? Does it matter? What do you guys think? Does it matter? You can just put yes or no on the chat. No. Thank you, Gazelle. Yes, no, it doesn't matter. Good job, guys. Miriam, thank you, Miriam. This will be x minus 9, x plus 9, or vice versa, right? It doesn't matter. Okay? How about this one here? What do you guys think on this one? Very good, guys. Very good. Ms. Rodriguez, you're almost there. Okay, but it's x minus 10, x plus 10. And that's a common mistake, guys, that at times students might put 50 because they think that you're adding. No, you're multiplying. That's why these are the perfect squares. And if you want to get more perfect squares, just go 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so forth, all the way to 12 if you want to or more. Okay? Okay, now, how about this one here? Something like this, I will say, hey guys, extra credit. And at times when I say that in my class, when people are falling asleep, I'll say something like that, and everybody wakes up all of a sudden, right? Because they want the extra credit. How about this one, guys? Can we factor it? Yes, you're right. Very good. X minus 5x minus 6y and 5x plus 6y. Okay, guys, you can do this like this because these are multiplied. If it was a plus there, you couldn't do that, right? Because if it was a plus, it would be a binomial or a family. You couldn't do that. But since here we're multiplying as a product, we can do that. Okay, now, hey guys, what would this one be? X squared plus 36. What do you guys think? Somebody, what would the answer be? Extra credit. Very good, guys. Very good. Hey, guys, here's a mistake that our students make. They think because, right, I was going on the pattern, x squared minus something, x squared y minus something, and they say x minus 6 and x plus 6. The answer is prime. And remember, guys, if it's plus, it's prime. Please do not forget that. Please, this is crucial. Do not forget that, okay? Okay, now, so check this one out. It's prime, right? Because it's a plus. It has to be a minus in between the two perfect squares. Okay, how about this one? What would it be? Are they both perfect squares? Yes, right? So what do you guys think? Yes, it can be factors, or what are the factors? Thank you, that was a good hint. Hey guys, look it up here. Very good, very good. So it's going to be x squared minus 4, x squared plus 4. Okay, now can it still be factored? Are these two perfect squares? Yeah, they are, right? And it's a minus, so that one can be factored. How about this one here? Remember, x squared plus 4 is prime, right? So that one cannot be factored, but this one can. So what would the answer be? This is x squared minus 4 will give you this one here, x minus 2x plus 2. And this one, all you do is bring it down. Something like this, you'll be seeing when you take pre-calc, when you're solving like for the zeros or trying to graph the function and trying to find the intercepts and all that stuff. This is very, I mean, all these are very important, guys, for your upper level courses. Okay, now, how about when it's 3 terms? When it's 3 terms, it's either by the x squared plus bx plus c form or the a squared plus bx plus c. This one I call it the easy factoring, guys. And I feel real confident that you guys are going to say, oh yeah, you know what, it's easy. Okay, and again, all this comes from the textbook, but I just put a little bit of twist on it. And here's where 2 students in the past actually gave me some information that they said they could do it better. And sure enough, we put it to the vote in the class, and this, oh yeah, Mr. says it's better. I mean, it improved your method. So every time that I show those parts, I always tell the audience or my students, you know what, guys, I got this from 2 students. I show them what I got, okay, but I'll show you right now what I'm talking about. Okay, now guys, when you have x squared plus bx plus c, this can be factored at times, but not every time. Okay, but if it can be factored, here's what it tells you about the signs. It's either the signs here are going to be the same or different. Okay. Okay, now, this is considered the bx term, which I should have put it there, but I didn't do that. And this is considered my constant term, okay? Hey guys, this term here, well, everything is crucial, but this will dictate 2 things, okay? I'm going to show you, I mean, the first one. The first one is a constant term. See, if that's positive, the signs are going to be the same right here. And if the constant term is negative, the signs are going to be different. Okay? So now, let me go a little bit quick, guys, because we have like about 8 minutes, okay? So here's how, I always give a quiz, like the second day of class when I'm teaching you 305, and the quiz is just tell me the sign, same or different, okay? And please, before you answer, take this into consideration. Okay, here, guys, the sign, same or different. What would it be? Same or different? Same, very good, right? Because the C is positive. How about that one there? Same or different? Very good, different, right? Because this is negative. Number 3, same or different? Different, very good, right? And at times, guys, my students ask me, they tell me, Mr. Sassi, that was an easy quiz. That was like for babies. I said, yeah, but it serves a purpose. What's the purpose of this? The purpose of this, guys, is for the students to focus on the constant term. Because at times they see the signs here different, so they say they're different. But this is a quiz for them to focus on the constant term. So right away, they should know the signs are different, or same or different, without even hesitating. Same or different. Like this is going to be the same, right? Now, guys, I'm going to do these. The first two, I'm going to go a little bit and slow, and this one I'm going to go a little bit quick because for lack of time. Okay, but here's where I got the info from 2 of my students that actually kind of perfected my well, it's not like perfect, but it's being perfected every semester when I get feedback from the students. Okay, now that was number 1, right? So the first thing, right, we got same signs. So this time you always bring it down, and right now I'll tell you the purpose why. So the same signs, well, that's negative, they're both going to be minus, right? So what's next? Get the factors off of 24, and that you guys should know I'm going to do right now because I already went over it. So how can I get 24? 1 times 24, 2 times 12, 3 times 8, 4 times 6, right? So, and okay, guys, this sign tells you what you do here. And this I got from a student because in the past I would say same signs is going to be the sum, right? Same signs means sum. So the student told me, hey, Mr. Sassi, you know what I do? I said, what? You know what? This sign, I put it here. I said, why? Because it tells me what to do. And at the time, guys, it didn't even cross my mind. And I figured, you know what? You're right. So this is what the student did. She would always do that step first because she would always forget what to do, add or subtract. So here, guys, we're going to add them. Okay, the sum of the 2 factors equals to the dx term. So this will be, we need to get minus 10, right? So we don't care about the positive or negative for now. We know we're going to add them. 25, right? They'll give me 14. They'll give me 11. They'll give me 10. So where's my match? My match is 6 and 4. So negative 6 minus 4 is where the negative 10 is, right? So that's my match. So that's the factor by, trinomial. Okay, let me try another one real quick. Okay, this one here. Different signs, right? This one you always break it down. And here's what I'm going to tell you what the other student mentioned. And that's why I bring the sign down because of the student that told me and the class agreed that it was easier than my way. So anyway, if you bring it down correct, and right now there's a reason for this. It's going to be minus and a plus because negative and a positive will give you a negative. So then what are we going to do with the factors? Add them or subtract them? We're going to subtract them, right? Because I got that from, I forgot to put the arrow there. Okay, we're going to subtract them, guys, okay? I forgot to put the arrow that goes here. Oh, there it is. Maybe the animation was a little bit late, right? So anyway, we're going to subtract them, right? So we don't care if it's positive or negative, right? We're going to subtract them. 30 minus, here we go. 30 minus 1 is 29. 15 minus 2 is, 13. 10 minus 3 is 7. 6 minus 5 is 1. So then, right, so this is my combination here. That's my match. So before you put them there, make sure that you get the BX term. So then, that's my combination. Okay, now, observation, okay, observation. Here's what this lady told me, this young girl told me to actually bring the sign down. Because I would say, hey guys, the sign of the BX term determines the largest factor. If the sign, okay, and here's what she came up with this. You know what, Mr. Sassi, you know what I do? I said, what? I bring the sign down. I said, why? Because the rule is, this sign determines the biggest factor. Oh yeah, that's right. And then she said, so if I bring it down, I don't have to worry about nothing, just put the bigger number there. My bad, let me go back, guys, hold on. Let me go previous and previous. Sorry about that, right? So that's why you always put the bigger number first, if you bring the sign down. So now on this one, guys, I'm a little bit quick because we're running out of time. So here, guys, I'm going to go a little bit faster, right? So this is going to be different signs, and it's going to be a difference, right? Subtraction. We bring the sign down, right? Like the student told me, and she did get extra credit, and I always say I got it from her. Anyway, right, it's going to be plus or minus, right? Because this one will bring it down, and they're going to be different. So then here, guys, factors of 20. There they are. We're going to subtract them, right? Where's the match, right? Isn't that 1? So the biggest factor goes first. Boom, there it is. How about this one here, right? We're going to add them, right? It's going to be the sum and same signs. So the sign comes down, and then we're going to be plus. We get the factors of 15, and we add them. Where's my match? 8, 5, and 3. Here, guys, it doesn't matter what goes first, but I like to keep it uniform, and some students always put the bigger number first. I mean, that way you have to think about which one goes first. According to what the student told me, that this one comes down, so the biggest factor, I always put it first. Okay, now, guys, we have like 7 minutes. Should I continue, or should we stop? We have like 2 more examples to do. Okay, I'm gonna keep going. Okay, now here's when okay, yes, this is the one here. Here's where our students have a hard time, because in 6.3 it tells you to do it by trial and error, and that's kind of hard, guys. Right now, if I have time, I mean, I would do it in the board, but I don't think I'm gonna have time. But anyway, this will be a little bit challenging to do it by trial and error. You have to be real good with multiplication and adding, subtracting integers, okay? So, but if you do it by grouping, it's going to be much easier. And here's the sign, the 3 terms, 4 terms, 2 terms factor, right? So here we're going to start with example number 1. The first step, what's my GCF? What they have in common? Nothing. Number of terms, I mean, are they in order? Yes. Number of terms, 3. Is it the easy factoring or by grouping? So it's going to be by grouping. So then we're going to multiply the A and the C. So we multiply 3 times 10 is 30. So then we get the factors of 30, right? Same thing, nothing new. You guys should know how to do this by now, because we did it earlier, right? So these are the factors of 30. Now, this tells you what we do here. We're going to add them, right? Again, we're going to add them. So the factors to get the BX term, this is my BX term. Remember, guys, I started with 3 terms, right? So my next one has to be 4 terms. This has to be converted to 4 terms. And how is it possible? By the factors here. Right? So here's my match. The match is positive 6x and positive 5x, right? So this is going to replace, right? We have 3 terms. We have, right? Those are 2 terms. So we must have 4 terms, right? Because it's by grouping. So these have to go, right? 4 terms have to go in there. Boom. Now you're set up with something that we did earlier, right? I did 2 examples of these. We factor by grouping. So factor by grouping, right? We have to factor the first 2 terms. What they have in common, right? Now it's going to be 2 terms. What they have in common, 3x. What's left? X plus 2. And I know I'm going a little bit fast, guys, okay? Because I want to cover this one at least. So remember what you put here, just put over there. It should work. And then when I will check it, we bring down the sign. What number times x will give me 5x, so it's 5. And 5 times x is 5x, and 5 times 2 is 10, so it's correct. Now this is something that we did earlier, like 2 or 3 times already. So what they have in common is x plus 2. What's left? 3x plus 5. And now it's factored. You see, these are the steps that I tell my students to actually follow. If you go from 3 steps to 2 steps, I mean to 3 terms to 2 terms, you're doing something wrong. You have to get these is the order that it's got to be. Okay, now guys, because we're running late, well, this is another one there. But you know what, guys? Let me go quick, and maybe I can answer some of your questions if you guys have any questions. Let me end the PowerPoint, okay? I'm going to end it. Hey, guys, if you guys want a copy of the PowerPoint, I'll be more than happy to share it with you. And then on another one, I even have the perfect cubes. I'll give it all to you guys. I don't care sharing my stuff with students or instructors. So if you want, maybe you can talk to Patricia, and we'll see how I can give it to you. Okay, now guys, let me show you something else real quick. Okay, guys, these are our plans from 1324. I even got it from the section in the book. So you have to factor these right here. And these are from 1325 when you do limits. right? And at times, guys, people get freaked out when they hear the word calculus, but calculus is not that hard. Is because some of the students they're not up to date with the algebra. You see, these are just factoring, and these are for the pre-calc. Okay, now, when I said and done, guys, you want me to do something on the board for you guys, or you guys want to leave because we have about 3 minutes? Or maybe Yvette can do something, Yvette and Ruben can do something on the whiteboard, or I'll do them here in my erasure board. Should I do some or not? What do you guys think? Okay. So then, guys, that's it for the PowerPoint, guys, okay? And again, guys, I mean, I do offer Sunday numbers. Every Sunday, my wife and I, we do Sunday numbers. I do the upper level courses, and my wife does the remedial. And if you want to know how to factor, guys, join Sunday numbers. Go with my wife, Mrs. Sassi. She does the remedial math courses, and she can show you how to do a factor in all these steps. Okay. Well, I'm gonna end the show now.
Yeah, I just want to remind you to sign in with the link that I placed in the chat. If you would like a copy of the PowerPoint and the other documents, as well as another factoring document where you can actually try them out and it'll let you check the answer. I will send that to you after today's session. And we do have tutors here in the room. So if you have questions, maybe you're working on your assignments right now for your classes, feel free to stay and hang out. We'll be here to help you.
Okay, now guys, can I say one more thing? Hey guys, here's where I do my Sunday numbers. So I'm saying this is as close as I can put it to actual like a face-to-face course. I do the punch and the board, and I believe, I mean, I'm real naive with using the pinning stuff in the mouse. That's why last week I was real like a little bit lost. But this is the way I like to do my assistance, like for tutoring and stuff, or my office hours. Okay, guys, so you're more than welcome to join me on Sunday.
Thank you so much, Mr. Azasi. Everybody who's enjoyed the session today, why don't you give Mr. Azasi an emoji round of applause in the chat? Post an emoji just thanking him for his awesome wisdom today and let him know that we appreciate him.
Well, thank you, guys. Thank you.
Thank you so much, Mr. Azasi. Does anyone have any questions for Mr. Azasi? Or if anyone would like to work with a tutor, maybe you have a couple more questions that maybe Mr. Azasi wasn't able to get to yet, just raise your hand and let us know, and we'll be happy to put you in a private breakout group with one of our online tutors, okay? Also, at this time, I'd like to invite you to next week's Tejano virtual events. On Wednesday, February 10th at 1 o'clock, we will have the STEM Grows and Bridges internship opportunities. On Friday, we'll have for careers and degrees at 1 o'clock, we'll be having tools to get you started and stay on track, presented by the counseling department. And then also on Friday at 3 o'clock, we'll be back here for Happy Math Hour once again, and we'll be reviewing exam 1 questions and answer session. So come with us, review your test, and be ready. Thank you all for coming today. Thank you again to Mr. Azasi and the math department for presenting this event for us. And we would like to thank you all for being a wonderful audience and hope to see you again soon. Again, any questions, feel free to raise your hand. And of course, we have some math tutors standing by to assist you if you would like.
Hey guys, I believe somebody wanted, if they could contact me, sure, you can. I'm going to post my email there on the chat, okay? You can contact me at any time. And if I can help you, I'll be more than happy to help you. Okay, I'm going to post my email there.